This lesson is all about ratios and fractions. Imagine you've got this delicious pizza in front of you, right? Straight from the oven, hot and soft, and you are eyeing for those slices. But then you started to question the existence of humanity because you couldn't believe what you saw on the pizza right in front of you. Pepperoni slices and chocolate bars on the same pizza. That's right, chocolate bars. A ratio is like a magical recipe, surely not with pepperoni and chocolate bars, that tells you the proportion of one thing to another. It's like saying for every pepperoni slice, we've got two chocolate bars. Simple, right? But here's where the fun begins. Well, surely not for your stomach though, if you have to eat it. We can write ratios in different ways. But today we are just going to focus on the fraction form. Picture a fraction like a mini pizza. Okay, you've got the top number, which is numerator, and the bottom number, the denominator. So if I tell you the ratio of pepperoni to chocolate bars is 1 to 2, just like this A to B, then we can write that as a fraction, 1 on top, because that's A, 1 to 2, and 2 on the bottom. It's like saying 1 yummy pepperoni slice out of every 2 melting chocolate bars. On the pizza, of course. Now, why do we bother with fractions, you might ask? Well, they are like the secret code that unlocks a world of mathematical possibilities. We can add, subtract, multiply, and divide them, just like we do with numbers. We can do whatever we want, like some crazy people would multiply chocolates with pepperoni on a pizza. Now, also imagine that if we put one slice of pepperoni, okay, a slice, and the two chocolate bars into a blender. I don't know why you would do that, but actually imagine we blend them, okay, and we make a yummy smoothie out of it. The total is now 3 parts, which we can use as a denominator of the fraction to represent the total, which is something that ratio can't do. So like A to B, then we can write as A plus B as the total parts. This is something that ratio can't do. So in conclusion, ratios as fractions are like the partners in crime in maths. They work together to make sense of the world, and we can do calculation using ratio and fraction all together. Now, who is hungry for some maths? Let's look at the first example together. So in the first example, we'll start off quite easy with some basic knowledge about fractions and ratios. For example, 3/5 of the class are boys. What fraction of the whole class is girls? So they're asking about the fraction of the whole class. Now we know 3/5, the fifth here means of the whole class. So therefore, if they're not boys, they're girls. Well, we're not going into the binary or the kind of gender issue. But in here, boys and girls, imagine we are just having boys and girls. So the other rest will be girls 2/5. Because 5 is the total parts. So 3 parts are boys, 2 parts will be girls. And part B, what is the ratio of boys to girls? So there are 3 parts of boys, as I said, and there are 2 parts of girls, so 3 to 2. If the question was girls to boys, the other way around, then you would have to do 2 to 3. Just be mindful with the position of the quantity or whatever they're asking you, the position of it. So you have to put the right number on the right side. The next example, in a class of 40 students, a quarter of the class are left-handed. The ratio of boys to girls in this class is 3 to 5. There are 7 left-handed girls. What fraction of the whole class is right-handed boys? You're given 2 categories of information in here. The first category is about the gender, the boys and the girls, and the second category is about left-handed or right-handed. Now you've learned something in the previous videos about presenting information like this. Do you know what's the best way to present this kind of information? I'll give you time to think. Two-way table. 2 categories of information, 2-way tables. So we can set it up. So to set up, we put 1 category on the row. So maybe boys in here and girls in here. And we also have total. And then on the row, we will put the left-handed and the right-handed and the total. Now what we know is that we can start to put some numbers in there. 40 students, that's a grand total, so that's out of 40, the total of a total is 40. A quarter of the classes are left-handed, so a quarter times 40, off means times, a quarter times 40, To multiply a fraction by a whole number, you divide by the bottom times the top. So 40 divided by 4 is 10. 10 times 1 is 10. So that's left-handed 10. Next, the ratio of boys to girls is 3 to 5. So that means altogether, total parts of boys to girls is out of 8. So out of 8. So as a fraction, we'll put out of 8. So what we can do here is we're sharing the whole class of 40 into parts of 8. So we can do 40 divided by 8, that's 5. That means for every one part, there are 5 students. There are 3 parts of boys. So in terms of boys, we can do 5 times 3 parts, which is 15. So 15 boys altogether. And for girls, that will be 5 parts of girls. So 5 parts of 5, which is 25. So we can put in the girls 25. We can add up these two numbers. It does add up to 40. So we know these two numbers are in the right place and the right position. There are 7 left-handed girls. 7 left-handed girls. So 7 in here. Then we can start to decipher our little maths puzzle in here. In a two-way table, you want to look for the row and a column that has only one gap in there. For example, just making an example in here, you can see in this column here, this column is doable because in this column, there's only one gap, which is the right-handed girls. Again, just to mention, for example, the first row is doable again because the only gap is the left-handed boys. But this row, the second row, is not doable because we've got so many gaps in there. Can you find one more row or column that is doable that you can start? Yep, this last column, because again, the only gap is here. So we can do it one by one. Let's start with the total. 10 plus something give us 40. This number must be 30. Right? Next one, the girls column, the middle one. 7 plus something is a total of 25. So the answer must be 18. We'll look at left-handed boys in here. Left-handed, not boys, left-handed. Across the total is 10. We've got 7 in here. This must be 3. And therefore, this must be 12. So you can sort of add them up. 3 plus 12 is 15. And 12 plus 18 is 30. So the numbers are working quite well together. So you know you're correct. What fraction of the whole class is right-handed boys? Right-handed boys is 12. So 12 out of 40. Now, sometimes they will ask you to simplify it, but in here they didn't ask you, so you're fine with that. You can go on and simplify it, and mark scheme would not deduct any marks unless they say give your answer in simplest form. If you do simplify in the wrong manner, say if you can't simplify it, say let's say for some reason I think divide by 4, top and bottom by 4, and I get 3 over 40 divided by 4. Make a mistake, let's say 11. It should be 10. You won't be marked down because they did not say you have to simplify, as long as you show this fraction. Okay, so by the way, the answer is 3 over 10 if you do want to simplify it. So here comes practice question 1. Pause the video, have a go at the question. When you're ready for the answers, you can press play. 3/7 of the pizza slices are Hawaiian, the rest are margarita. Or any Hawaiian lovers in here? I'm a big fan of Hawaiian. I love pineapple on a pizza. I might have offended a lot of Italians, but still, food is food, food is love. So please don't blame me for that. Part A. What fraction of the whole pizza is margarita? So the whole pizza, 3/7 of the pizza slices are Hawaiian, the rest are margarita. So in total, there are 7 parts, 7 slices. How could you divide a pizza by 7? Well, don't know. So the rest will be 4/7. Part B. What's the ratio of Hawaiian to margarita? 3 to 4. Here comes practice question 2. Slightly a bit more difficult, but pause the video, have a go at the question. If you're unsure or you're ready for the answer, you can press play. There are 150 cars in a car park. The ratio of diesel cars to petrol cars are 2 to 3. A fifth of diesel cars are red. 4/9 of petrol cars are red. Are more than 1/3 of the cars in a car park red? Show you're working. Again, 2 categories of information. The first one is whether they're diesel or petrol. The second one is whether they're red or not. So, two-way table. So we have diesel on here and petrol and the total. So we can have red and not red. And the total. Okay, right. Next, 150 cars in car park, so 150 total in here. The ratio of diesel to petrol is 2 to 3. So we are showing, so out of the total is out of 5. The car's out of 5. So I can do 150 divided by 5 to work out one part. That's 30. That's for one part. Diesel has 2 parts, so 30 times 2. And the petrol, there are 3 parts, so 30 times 3. 30 times 2 is 60. 30 times 3 is 90. So that means the total diesel costs are 60 and total petrol cost is 90. Next, 1/5 of means times 1/5 of diesel cost. So how many diesel costs? 60. So 1/5 of 60 divided by the bottom times the top. That's 12. So our red. So it means red diesel is 12. 4/9 of the petrol costs are red. 4/9 of the petrol cost. Petrol cost then 90. So divide by the bottom times the top. 90 divided by 9 is 10. 10 times 4 is 40. So the question are more than 1/3. We don't know. We have to do the calculation. So let's finish a two-way table. So again, we look for column or rows that only has one opening. For example, the diesel column in here, there's 12 and 60. There's a gap. 60 take away 12 is 48. Same for the petrol. There's a gap in there. 90 take away 40 is 50. Look in the row, the first row about the red cars, we can see there's a gap in here, which is the total for the red. 12 plus 40 is 52. 48 plus 50 is 98. To double check your answer, add up these two numbers, 52 plus 98. Just double check. 2 plus 8 is 10. 5 plus 9 is 14. Plus 1 is 15. So it works. That means this two-way table is correct. Then we can finally look at the question. Are more than 1/3 of all cars in a car park red? So which number in this two-way table are they looking at? Now, if you haven't done a two-way table, you can copy this and pause the video and have a go with the rest of the question, see if you can answer it. But if you have done it, then here we go. So 1/3 of the car is red. So 1/3 of the whole cars altogether, there are 150 cars. There are 50. That means the question is, are there more than 50 red cars? Well, if we look at two-way table, red cars total is 52. So the answer is yes. Okay, there are 52 red cars. Okay, so which is more than a third. So now you can't, in exam, you can't just say yes or no. The reason being is you do have to show all your working out. Otherwise, you get no marks for just by saying yes or no. Because ultimately, if you don't show working, it's a 50-50 chance of guessing. And you won't get marks for just guessing. Unfortunately. Practice question number 3. Again, pause the video. I'll let you have a go. This is quite similar to previous one, so hopefully after the previous example, practice question, if you can't do it, let's try this one, see if you can do it. Okay, have a go at the question. When you're ready for the answer, you can press play. In a street of 96 residential properties, the ratio of bungalows to townhouses is 7:5. 3/8 of the properties are semi-detached, the rest are detached. Half of the bungalows are detached. What fraction of the 96 properties are detached townhouses? Two categories, again, so you want to use two-way table to help you. So first of all, with bungalows and townhouses, so put bungalows for B, townhouses for TH. For each column, we need a total. And then what's on the row? We've got detached and semi-detached. So detached and semi-detached. Oh, let me put on top here. Actually, semi-detached and detached, and then total as well. Okay, so 96 is a grand total. The ratio of bungalows to townhouse is 7:5. That means out of 12. So out of 12, so we can do 96 divided by 12 to work out one part. That's 8. 8 times 7 is 56. 8 times 5 is 40. So there are 56 bungalows. 56 bungalows, 40 townhouses. 3/8 of the properties are semi-detached. Now, what would you multiply 3/8 by? Of means times. Of what? Of the bungalows, of the townhouses, or of the total? Well, it didn't say bungalows, townhouses, so you would assume it's a total. 96. So 3/8 times 96. 96 divided by 8 is 12. 12 times 3 is 36. So 36 are semi-detached. The rest are detached. That means the difference here will be 60. So 60 are detached. Half of the bungalows are detached. Half the bungalows, so half of 56 is 28. 28 of the 28 are detached. So 28 are detached. Therefore, semi-detached is also 28. Next, you're done with all the information. You just have to fill in a two-way table, complete a two-way table. So 28 plus 8 is 36. 28 plus 32 is 60. 8 plus 32 is 40. So everything kind of works like a Sudoku. So, right then, time to pick up the information that we need, pick up the right information that we need from the question. What fraction of the 96 properties are detached townhouses? Detached townhouses is 32, so 32 out of 96 is the answer. If you do want to simplify it, both numbers actually go into 32, so it'll be 1 out of 3, but that's equally good enough. Next example. Now, these are more like a GCSE exam question that you sometimes see in a paper where they give you two kinds of ratio and you need to connect them together. Now, I'll teach you one easy way to do this type of question. Example, given A to B is 2 to 3 and B to C is 4 to 7. Find A to C. The way I do it is you write them all like this, list them out A to B to C. Now, A to B is 2 to 3, so I put 2 to 3. Now, 4 to 7, I cannot put it here. The reason is because there's a 3 in the middle and B already, so we can't put a 4. So we have to put it underneath 4 to 7. Now, think of it like a bridge. 2 to 3, 4 to 7. You can't cross a bridge from A to C because these numbers are not matching. So you need to make them match first. So you need to think about a number that both 3 and 4 go into, or essentially the LCM of 3 and 4. The answer is 12. So we're going to make them both out of 12. So how do you do that? Now for the first one, if I want to make a 3 into 12, I can multiply the top one by 4. For the bottom one, if I want to make a 4 into 12, I will have to multiply by 3. So 2 times 4 is 8. 3 times 7 is 21. Now, last answer question, find A to C. So now we know A to C is 8 to 21. Next example, A over C is 2 over 7. Now, if you remember what I said in the beginning about a fraction, we know A over C, the division line, also means ratio. So A to B same as A over B. So we can rewrite A to C is 2 to 7 and B to C is 3 to 5. Now note, this time C is the bridge. So instead of writing A to B to C have the same setup, I'm going to put C in the middle because C is the connector between A and B. So A to C is 2 to 7. B to C is 3 to 5, but we have to put C first. So it'll be 5 to 3 like this. Just be careful what number you're putting underneath what letter. 7 and 5, the lowest common multiple is 35. So I need to multiply the top line by 5 because 5 times 7 gives you 35. The bottom line, and you make it 7. Or you can think of basically like cross multiply. So 2 times 5 is 10. 3 times 7 is 21. Therefore, A to B is 10 to 21. Now, if you find A to C to B too confusing, you can also do A to B to C. So A to C is 2 to 7. I just need to make sure I put it in the right place. B to C is 3 to 5, so 3 to 5 in here. Again, you can see C is the only one with two ratios, top and bottom, so I need to make sure they are the same, and that will be 35. So when you multiply the bottom line by 7, you get 21. To get from a 7 to 35, you times it by 5. So 5 times 2 is 10. So you get 10 to 21 as your final answer as well. So this is practice question 4. This will be the last practice question before you move on to the more problem-solving ones, a bit more wordy ones. So pause the video, see if you can understand what I've just taught you and apply into this practice question. Pause the video, have a go at the question. When you're ready for the answer, you can press play. Right, A to B, 3 to 2, B to C is 3 to 5. So A to B to C, 3 to 2, 3 to 5. We need to multiply the first one by 3. If you do a shortcut, basically cross multiply. The second one times 2. The reason this shortcut works is because you essentially work at the LCM of both numbers 2 and 3. So the first one, if you make this 2 and 3 is 6. So 3 times 3 is 9. 5 times 2 is 10. The answer A to C is 9 to 10. Easy peasy, lemon squeezy. Here comes practice question 5. About Harry, Hermione, and Ron. I used to have so much trouble speaking the name Hermione. I still struggle a lot, so please bear with me if I say it wrong. I do apologize. But regardless, pause the video, have a go at the question. When you're ready, press play. So Harry, Hermione, and Ron sold all their magic wands. They decided not to do Harry Potter anymore. Well, guess why there isn't a Harry Potter number 8? That's because they sold all their magic wands. They can't defeat anymore Voldemort. Obviously defeated, but any more Voldemorts. Received £2,200 together. That's worth nothing for the magic wands. They decided to share the money, however, not very fairly. Harry's share to Hermione's share is 41, and Hermione's share to Ron's share is 37. Work out how much each of them get. So it's just a very similar question to the previous one, but it's just given this time a total to work with. So essentially what you want to do is, first of all, you do want to use the common ratio to work out the ratio in one line, because this is now broken into two, 41 and 37. So we've got Harry and Hermione, HG, and Ron's R. So we've got 4 to 1 and 3 to 7. So what's the LCM between 1 to 3? The answer will be 3. So the first one, to make a 1 to 3, we times it by 3. So 4 times 3 is 12. The second one, to make a 3 into 3, you don't have to do anything. So in total, the ratio they're sharing is 12 to 3 to 7. Now we're sharing a £2,200 together. The method that I use to share ratio of a total is, I call it ADM method. So what does that mean? A means add the ratio. So add the ratio, 12 plus 3 plus 7, which is 22. D stands for divide by the total. Divide by total is £2,200 divided by 22 parts. That means that's £100 per parts. M, guess it, multiply. So multiply each ratio. So for Harry, his amount is 12 parts. Of course, Harry is the main character. Of course, he will get more. 100 times 12 is 1200. For Hermione, can't even spell, I can't say her name, and I can't spell her name. Hermione is £100. She only got 3 parts times 3, which is £300. And Ron is £100 times 7, which is £700. So that's the amount they each get. Last practice question of the lesson. Have a go with the question. When you're ready for your answer, you can press play. There are 3 flavors of sweets in a jar: apple, orange, and lemon. And lemon's the best. The ratio of orange and apple to orange is 2 to 3, and the ratio of orange to lemon is 4 to 3. Actually, I take it back. Maybe orange and lemon, they're both the best. Apple, depends on the brand, I say. It is known that there are 60 more orange sweets than lemon sweets. Work out the minimum number of sweets inside the jar. So now, again, you see 2 ratios. There's a common common quantity, which is orange, common flavor. So you do have to put in A to O to lemon to make sure they have this same one line of ratio. 2 to 3 is now 4 to 3. We've done this quite a few times already in the video, so I'm not going to go through how we do that. So we can times this by 4, times by 3, 8 to 12 to 9. There are 60 more orange sweets than lemon sweets. What that means is the difference in parts equals 60. So the difference of orange to lemon sweets in terms of ratio is 3. So 3 parts of difference. And 3 parts of difference is equivalent to 60. Oh, funny, I just used orange without realizing. Orange color, orange sweets. Yum. 60, that means 1 part is 20, because you divide both sides by 3. Divide by 3, divide by 3. That means 1 part is 20. So therefore, if 1 part is 20, we now know apple got 8 parts, orange got 12 parts. and lemon got 9 parts. So we can multiply each number of parts by 20. Now, before I want to give you an answer, you might be thinking, why did I not use this method called ADM we just did? The reason being that ADM is only usable when you're given the quantity as a total amount. This 60 is not a total. This 60 is only the difference between 12 and 9. That's why we can't use ADM method. So ADM only workable for giving out total. Right, so for apple, just finish off, will be 20 times 8, 160. Orange, 20 times 12, which is 240. Lemon, 20 times 9, 180. By the way, these questions could be in a non-calculator paper. So if you're giving calculator work with all these numbers, brilliant. But if they don't, you can see the numbers are meant to work quite well together with that calculator. So altogether, the total, they want a minimum number of sweets inside a jar, the total, and then more up, 0, 10, 8, 3, 4, 580 sweets is the answer. That's quite a lot.